Welcome to Study Loop.
For this problem, we are asked to look at two different reactions and determine which one has the larger equilibrium constant. At first, there seems to be a lot going on here, so let's look at the reactions one at a time. In the top reaction, you can see that all of the spheres start separated, so we have A and B separately. Let's let the yellow dots be A and the brown dots be B. We can see over time some of these spheres start to join together and make the product AB. By the time we get to our last two pictures here, at 40 and 50 seconds, we see the same thing in both of them. There are 2A, 2B, and 4 products joined together. Since this is true both at 40 and 50 seconds, we're going to go ahead and take this as the equilibrium state for this system. We're going to remember our equilibrium equation, which is products over reactants. And if we put in these numbers, we find that we have 4 over 2 times 2 equals 1. Now let's look at the bottom reaction. Here we once again start off as all separate atoms with our X. We could let that be red, and Y let that be blue. And once again, by the time we get to the last end of the reaction here, we see that we have the same state at both 40 and 50 seconds. In this case, there are 3 red, 3 blue, and 3 of the product, XY. Since we see this in both the 40 and the 50 second time, we're going to let this be our equilibrium conditions. So we count 3x, 3y, and 3xy. The equilibrium constant for this equation is going to be the concentration of xy over the concentration of x times the concentration of y. So that's going to equal 3 over 3 times 3, which is 1/3. And since this 1/3 is less than the 1 we found for the above reaction, we will find that the larger equilibrium constant is for the first reaction, where A plus B is in equilibrium with the product AB.